Headless Chrome doesn't hide a thing by itself. It's just Chrome running without a visible window. Same rendering engine, same JavaScript engine, same network stack as the browser sitting in front of you right now. And Google shipped it back in 2017 so developers could run automated tests and scrapers without a display server attached to the machine. It was never built as a way to hide from anything. It was built to save resources on a server that has no monitor plugged into it. That distinction matters more than people give it credit for. I run proxy infrastructure and cloud phones for multi-accounting work, and part of my job is testing anti-detect browsers against real fingerprinting checks before I ever trust one with an account that matters. So when people tell me headless mode is some kind of stealth mode, I want to walk through why that's wrong and where the actual leak really lives, because the answer changes what's worth paying for in this space. The mistake starts with the name itself. Headless sounds like it means invisible, but it's a deployment mode, nothing more. The stealth problem showed up later, once bot operators started driving headless Chrome, and the tools built on top of it like Puppeteer, Playwright, and Selenium CDP driver to automate logins, scraping, and account creation at scale. Platforms noticed the traffic pattern that all of this automation produced, and they built detection specifically around it, not around the concept of a hidden window. Here's the part most people get backwards. The real fingerprint isn't the missing window at all. It's the protocol running underneath it. Most automation frameworks don't talk to Chrome through some special headless APIs built just for that purpose. They talk through the Chrome DevTools protocol, CDP, the exact same protocol behind the DevTools panel that ships inside any normal copy of the browser you already use every day. CDP lets an external process open tabs, navigate pages, read the DOM, intercept network requests, and inject JavaScript, all of it running over a WebSocket connection straight into the browser process. And here's the part operators genuinely need to understand. That connection leaves traces that exist whether or not the window is visible on a screen anywhere. The protocol doesn't care if there's a monitor attached. You can run Chrome in full-headed mode, a real window, a real display, even a visible mouse cursor moving across the screen, and still be driven entirely by CDP underneath. Detection systems built to flag CDP presence catch both cases equally. Switching from headless to headed alone does not remove the signal a page can pick up on. The protocol connection is the actual tell here, not the missing window everyone assumes is the problem. There's a concrete example worth knowing because it shows how deep this goes. When a CDP client sends the runtime enable command, Chrome starts forwarding JavaScript execution context events to that client behind the scenes. That single command changes internal browser behavior in small, measurable ways. A page can sometimes detect this indirectly, through timing differences or through how certain error objects get constructed once that command has run. Detection scripts have been built around exactly that side effect, and Google isn't racing to patch it, because from Chrome's point of view, CDP is working exactly as designed. The leak is a byproduct of the protocol doing its job properly, not a flaw in it. Before protocol-level detection got this sophisticated, most bot checks just looked at a handful of simple JavaScript properties. There's a flag on the browser's navigator object called WebDrive, which exists specifically so automated sessions can be identified, and which Selenium sets to true by default without you asking it to. There's also an empty or oddly small list under navigator plugins and MIME types, since a fresh automated profile never accumulates the plugin clutter a real aged browser naturally picks up over months of normal use. Few more of the classic tells round out that older generation of checks. A missing or incomplete window.chrome object inside the page, because some automated setups never initialize it the way a normal browsing session does by default. A mismatch between what the permissions API reports for something like notifications and what the notification object itself separately reports. A small inconsistency that shows up far more often in automated setups than in real ones, and a toString check run against a suspicious function. Since a genuinely native browser function returns native code when you call toString on it, while a patched or proxied version of that same function often gives itself away right there, because faking that exact native signature is harder than it sounds. None of that is exotic, and honestly, Any single one of those checks is easy enough to patch on its own with a few lines of injected script. The real problem for automation is that detection scripts don't stop at one check and call it a day. They stack dozens of these signals together and score the combination as a whole. So patching 3 obvious flags while missing a 4th still gets the whole session flagged, because the score crosses a threshold regardless of which specific check tripped it. This is exactly where it gets harder, and where a lot of tooling that claims to beat headless detection quietly falls short of what it advertises. Patching WebDrive to read false, or injecting a fake plugins array into the page, only touches what a page can observe through JavaScript running inside that page. It does nothing whatsoever about what the browser exposes at the network and protocol layer, underneath the page entirely, in places JavaScript running on that page can't even reach. Take TLS and HTTP2 fingerprints as the clearest example. The order and specific values inside a Chrome TLS handshake, and the settings inside its HTTP2 frames, stay remarkably consistent for any given Chrome build and version. If an automation stack pairs a spoofed user agent string with a TLS fingerprint that doesn't actually match that claimed browser version, the mismatch is fully visible to anything inspecting raw traffic. And services like Cloudflare and Datadome check exactly that before any JavaScript on the page even gets a chance to run. Samit sapeni submissions, samit samay hamdas kepredasa check itself as a second example. If a detection script manages to run code in a context that checks for an open debugging port or for CDP-specific global variables, no amount of JavaScript object patching hides the underlying fact that the tab is attached to a live remote debugging session somewhere. And take timing as a third example. Every CDP command adds a small round trip between the automation script and the browser process itself, a round trip that a real person clicking a mouse or typing on a keyboard simply never has. Some detection systems look closely at the timing distribution of clicks and key presses relative to page load, and CDP-driven interaction tends to carry a noticeably different rhythm than an actual hand resting on a trackpad. None of those three get fixed by editing a JavaScript object before the page loads, because they don't live at that layer at all. Fixing them properly means either not routing the sensitive parts of a session through CDP in the first place, or running a genuinely modified Chromium build where the patch happens below the JavaScript layer entirely, down near where the protocol and the rendering engine actually live and do their work. That's the real product category multilogin, Go login. Camelio adds power and Dolphin NT compete in. And it's worth being precise about what they're actually doing under the hood. The better built tools among them don't just overwrite a handful of navigator properties from a bit of injected script. They run modified Chromium builds, where the values that feed a fingerprint, things like canvas rendering output, WebGL renderer strings, audio context data, font enumeration lists, hardware concurrency, and screen properties, all get adjusted at a lower level, with every profile isolated in its own cookie jar, storage, and cache, so profiles never cross-contaminate each other over time. Some of these tools also route CDP-based automation through their own internal layer instead of exposing a raw debugging port directly, specifically to avoid the whole class of leaks I just walked through. How thoroughly any given vendor actually does this changes from release to release and from vendor to vendor. So I'm not going to hand out a verdict on a specific product's current build without running an actual fingerprint test against it myself first. What I will say, from running proxy and cloud phone infrastructure for exactly this kind of work, is that the gap between changing a few JavaScript values and building a genuinely different fingerprint surface underneath is enormous, and it's the single biggest quality difference separating tools in this whole category. None of that makes any of these browsers undetectable, and nobody testing them honestly should ever tell you otherwise. Detection platforms like Cloudflare, Datadome, Akamai, and Human don't rely on any single signal to make a call. They combine TLS and HTTP2 fingerprints, JavaScript-level environment checks, CDP artifacts wherever they're reachable, behavioral signals like mouse movement and typing cadence, and account-level signals like IP reputation and session history, then score the entire session together as one combined picture rather than a pass or fail on any one check. A profile can pass every individual JavaScript check on the list and still get flagged because the TLS fingerprint underneath doesn't match the claimed browser, or because 10 supposedly different accounts are all quietly sharing a fingerprint cluster that's statistically implausible for 10 different people to produce independently. That's exactly why isolating each profile properly, a separate fingerprint, separate cookie storage, and in serious multi-accounting setups, a separate IP through mobile or residential proxies, rather than data center ranges, matters more in practice than any single clever trick sitting inside the browser itself. A clean fingerprint sitting on top of a flagged data center IP still gets caught more often than not. An imperfect fingerprint sitting on a clean mobile IP with a consistent account history sometimes survives longer than the fingerprint quality alone would ever suggest, because detection is scored across many weighted signals, not decided by a single pass or fail gate on any one of them. This is the part a lot of buyers skip over when they're shopping for a browser, since a glossy feature list about spoofed canvas values means very little if the proxy underneath it is a cheap data center block that's already been flagged 1,000 times by the same platform. That's also why I keep coming back to infrastructure and behavior alongside the software itself, rather than treating the browser as the whole solution on its own. Warming an account slowly, keeping session activity consistent with the story the fingerprint and the IP are telling together, and not reusing the same proxy across accounts that are supposed to look unrelated. All of that shapes the score just as much as which vendor built the Chromium patch underneath the hood. So here's where I land on all of this, after testing plenty of these tools against real checks myself. No anti-detect browser makes an automated or multi-account session undetectable. And nothing in this video is a promise that any tool out there prevents a ban, because detection techniques keep moving forward on both sides of this at once. What actually separates the tools worth paying for from the ones just papering over the obvious checks is whether their fixes happen down at the protocol and browser engine level, or only in a bit of script injected after the page has already loaded. If you're evaluating a browser for this kind of work, specifically how it handles CDP exposure and TLS fingerprint consistency, not just whether one flag happens to read false in a console. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks are waiting at antidetectreview.org, so go take a look and subscribe if you want the next breakdown before anyone else sees it.